Okay, so now we're going to talk about solving using double angles. So we've been doing solving for a little while. Now we're just going to kind of throw some double angles in there. So here's our equations that we're going to possibly use, and we're going to use them all with substitution. So I have 2 cosine squared theta equals 2 minus cosine 2 theta, okay? So what I'm going to do is with this cosine 2 theta right here, I'm going to replace it with one of these 3 cosine formulas. So if I look at what I'm given, this side has a cosine squared. So I'm going to look over here. If I use this equation, that's going to introduce a minus sine squared. If I use this equation, it's going to introduce a minus 2 sine squared. But if I use this one, that keeps it all in terms of cosine squared. So that's the one that I want to use. So I've got 2 cosine squared theta equals 2 minus cosine squared theta minus 1. Oops, sorry, 2. Okay? So, God, this is really, really fat. So I'm going to make that a little skinnier. Okay. So I've got 2 cosine squared theta minus 1. And I went ahead and put that all in parentheses because I'm subtracting all of this. So the whole reason I substituted this in is because this is getting rid of this double angle right here. I don't know how I can go ahead and combine these, okay, unless I get rid of that 2 right in front. So I'm doing that by substituting that in. So now I'm going to go ahead and I'm going to distribute that subtraction sign. So I've got 2 cosine squared theta equals 2 minus 2 cosine squared theta plus 1. Okay. So now I'm going to go ahead and combine like terms. So I'm going to go ahead and I'm going to add the 2 cosine squared to both sides. And I'm going to combine this 2 and this 1. These are all on the same side of the equation, so don't do the mistake of making this into minus 1 because you're moving it around. You're just keeping it on the same side of the equation, so it's 2 plus 1. So here I've got 4 cosine squared theta equals 2 plus 1 is 3. Okay, so now I'm going to keep on solving. Wish I could default to a skinny pen here. I'm going to divide by 4, and that's going to give me cosine squared equals 3 over 4. Now, in order to get cosine all by itself, I have to square root it, right? So when I square root, I have to be sure and remember my plus or minus. So I've got cosine theta equals plus or minus the square root of 3 over 2. So that's when I take out my unit circle and I look at it and I see every single time that cosine is equal to plus or minus square root 3 over 2. And on my unit circle, that's going to be at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. That is going to be my value for theta. So that is your solution. This is your answer right here. So all we're doing is the same stuff we've been doing where we were solving for theta, but I just substitute in a double angle right here. That's all I have to do. Okay, let's try another one. So right here, oh shoot, I just noticed when I wrote this, I wrote it incorrectly. That should be sine. All right, we've got sine 2 theta. Okay, so now I'm going to use one using the sine equation. Last one we did cosine 2 theta. This is a sine 2 theta. Now, if I notice, I have a cosine and a cosine, but if I'm using sine, I have to introduce sine and cosine. Like I have to have both of them there. So let's go ahead and substitute that in. So I've got cosine theta equals, and sine 2 theta becomes 2 sine theta cosine theta plus 3 cosine theta. Now right here, everybody wants to divide by cosine, and I can't do that. What I need to do is I need to go ahead and combine like terms, and I need to subtract my cosine here over here. The reason I'm doing that is because I have to end up factoring. Okay, we have to remember that we want to factor in these kinds of questions. So 3 minus 1 is 2 cosine theta. So this is what I have. So you can pull out a 2, and you can also pull out a cosine. So that's what I'm going to do. Pull out a 2, pull out a cosine. Okay, so I'm going to do that from all of them. So I'm going to write that on the outside, 2 cosine theta. And on the inside, if I divide this by 2 cosine theta, I'm left with sine theta. And if I divide this by 2 cosine theta, well, I'm left with 1. Okay. Now, I'm going to set up my 2 equations right there, where I've got 2 cosine theta equals 0, and sine theta plus 1 equals 0. So when I'm solving here, I end up dividing by 2. Well, 0 divided by 2 is just 0. And sine, I'm going to get minus 1. So that's when I take out my unit circle, look at it, and I've got theta equals, when it equals 0 here is at pi over 2 and 3 pi over 2. And sine equals negative 1 at 3 pi over 2, but not at pi over 2. So I get both of these answers from this one. It's okay that I don't get anything else from this one. Okay. The big mistake would have been if you had, say, for example, instead of subtracting cosine here, say you subtracted 3 cosine. So what you would end up having here, why is this doing this so weird? If I have cosine 2, cosine theta equals 2 sine theta cosine theta plus 3 cosine theta. Okay, so let's say we have this. You see this? It still shows I have an eraser thing. I don't know. Whatever. Let's say we subtracted the 3 cosine that some people are going to want to do. If I do that to both sides, minus 3 cosine theta, I end up with 1 minus 3, so negative 2 cosine theta equals 2 sine theta cosine theta. And some people want to divide out the negative 2 right here, or even just cosine. So let's pretend, now this is not correct. If I divide by cosine theta, oh my God, this lag is killing me. Got cosine theta. It cancels out here and it cancels out here, and then I end up with negative 2 equals 2 sine theta. Divide by 2 and I end up sine theta equals negative 1. Well, that's not wrong. I sure as heck have that right here, and these are the same, right? But it completely leaves this factor out. So when you're doing this, you're literally canceling out an entire factor, and you can't do that. So you would have only gotten half the answer. You wouldn't have had that one at all. So be sure and not do that. You want to set it equal to 0, and you want to pull it out. Good way to remember it is if you know that you can cancel out, if you have that urge to cancel out that cosine and divide by cosine, that means if you set it equal to 0, you can go through this process right here of factoring it out. So instead of dividing by it, you just pull it out and factor it out. That's what you need to remember to do instead, okay? So that's how you solve using double angles.